Okay, so equations with two absolute values. So we're talking about a situation like this, where we would have something like the absolute value of ax plus b equals the absolute value of cx plus d. Something like that situation. Well, what I do is I keep the absolute value on the left as the one like in the other absolute value equations we've been working with. And then I make the two cases out of the one on the right. So I would set this up as ax plus b equals the opposite of cx plus d, or ax plus b equals just cx plus d. So what's inside the absolute values, either they're equal to each other, that's the case on the right, or one is equal to the opposite of the other. And like I said, I just keep the one on the left the same and change the one on the right, because that's what we do in the other absolute value equations. You don't want to change both sides, because then you're back to case on the right, okay? So just be careful on that. So I keep this left-hand part the same for both setups, and then on the right-hand side, I make this the opposite, and then I keep it the same. So those are the two cases. So that's what we're going to look at. They don't usually have a lot of these, but it'll be good for our solving equations. So we have an example here where we're going to do that. So we have the absolute values. They're both isolated, but we'll just take the 7x minus 3. And I usually do the negative case or the opposite case first, so I don't forget about it. Opposite equals the opposite of 3x plus 7. It would have been nice if it had some different numbers in this problem, but that's okay. And there's always more examples in the book. There's more examples that you can see. I don't do the first examples because those are done in the book, so you have those to look at. I always do the second example. Okay, so there's this one. That's the opposite case. And then the other case, or 7x minus 3 equals, just 3x plus 7. Okay, now we have two equations. We're going to solve those. So 7x minus 3 equals negative 3x plus 7. Mistake. Minus 7. Got to distribute there, right? Okay. Now I'll add 3x to both sides, because remember, when we're solving in an equation, we need to get the x's together on one side. So that gives me 10x minus 3 equals negative 7. So I'll add 3 to both sides. We're going to run out of room. 10x equals negative 4. I'll divide by 10. This is good algebra here. X equals, and then I want to reduce that fraction, negative 2/5. So that's what I get for that one. And on the other side, okay, so subtract the 3x. So I get 4x minus 3 equals 7. Add the 3. Then I get 4x equals 10. Divide by 4. And I get 5/2. Now, those happen to be opposite reciprocals, which is just kind of a fluke. It's the numbers that they picked. That's why it's doing that. So they could have had 5 and 2 on one of the sides, so then that would have been different. But okay, so the answers are negative 2/5 this time and 5/2. So it's just a fluke that those kind of numbers were the same. Okay, there you go.